right, now we're into the second part of our equations and inequalities unit, which is focusing on inequalities. So here's the key for us. In all the problems we've been doing so far, we've had an equal sign. So when it says x equals 5, it means there's just one answer, 5. Okay, that's the only number that I can place in for x that would make this a true statement. Now we're going to move to inequalities. So this one we would read as y is less than 2. Well, there's lots of numbers that are less than 2. It's not just one number. So like a 1 is less than 2. 0 is less than 2. -5 is less than 2. -8 is less than 2. 1.5 is less than 2. 0.25 is less than 2. There's lots and lots and lots of numbers that are less than 2. So when we're solving an inequality, or where we're looking at the solution to an inequality, we have to remember that all of these numbers over here, sorry, that's a really bad arrow, are less than 2. They all work in this particular inequality. An equation has one nice, neat answer. An inequality has hundreds, thousands, an infinite number of numbers that are less than 2. So the idea is that it's not just one nice, neat number anymore. It's a whole range of numbers that could work. All right, real quick. You've seen these before. Sometimes in elementary school, we think of them like the alligator ate the bigger number. But these are inequality symbols. The first two are less than. And people sometimes remember less than is kind of think of the letter L. It opens up going to the right, so it is less than. The other one is greater than. And then we have less than or equal to. Okay, that's like a less than with a little bar underneath of it. Think of it kind of like a less than symbol and an equal symbol all being combined together. It can be less than the number or it can be equal to the number. I'm okay with either. And then the last one is greater than or equal to. And the more you see these come up in problems, the more that you work with these, the more it's going to start to make sense for you, and you're going to be able to see how to use them in a problem. But for right now, get those down, and we're going to refer back to this a bunch today. All right, next part. Solutions to an inequality. So we talked about that in that first example. There are lots of numbers that can be solutions. It's not just one nice, neat answer anymore. So here we have f plus 2 is less than 9. So some number plus 2 is going to be less than 9. We want to know, is a 5, a 6, a 7, or an 8 going to be a solution? It could be none of them. It could be one of them. It could be two. It could be all of them could be solutions. But we do it by checking. We plug in our number in for f. So 5 plus 2. 5 plus 2 is 7. Is 7 less than 9? Yes. So 5 is one of my solutions. So now I check again. Let's try 6. So we plug it into the inequality. And then we check. 6 plus 2 is 8. Is 8 less than 9? Yep. So 6 is a solution for it. Then we plug in 7. 7 plus 2, is that less than 9? Well, 7 plus 2 is 9. Is 9 less than 9? No, it's equal to 9, so 7 doesn't work. And then 8. 8 plus 2 is less than 9. Well, 8 plus 2 is 10. So basically think of it as you're doing the problem on one side and comparing it with the other. Is 10 less than 9? No. So 7 and 8 are not solutions, but 5 and 6 are. Basically, I can plug it in, do the math, and yes, it does make sense. So let's see that in action down here. I want to check, does a 4, a 5, a 6, and a 7, do those work in these inequalities? So talk to yourself. Plug in 4. Is 4 less than 5? Yeah, 4 is less than 5. Is 5 less than 5? No, 5 is not less than 5. Plug in a 6. Is 6 less than 5? No, 6 isn't less than 5. And then 7. Is 7 less than 5? Nope, that one's not going to work either. So the only one that's a solution is 4 in this case. But you're just plugging each of them in, talking yourself through it, and see if it makes sense. Be careful on the next one when the number is first and the variable is second. It can be a little tricky. But a lot of times say that inequality to yourself, greater than or equal to. So is 8 greater than or equal to 4? Yeah, 8 is greater than 4. What about 5? Is 8 greater than or equal to 5? Yeah. Is 8 greater than or equal to 6? Yeah. Is 8 greater than or equal to 7? Yeah, that one works as well. So in this case, all of those numbers happen to be solutions. So next one, x is less than or equal to 6. So try 4. Is 4 less than or equal to 6? Yeah, it's less than 6. Then we do 5. Is 5 less than or equal to 6? Yep, 5 is less than 6. Is 6 less than or equal to 6? This one's tricky. No, 6 isn't less than, but I'm also okay with it being equal to. Yeah, 6 is equal to 6. And then 7. 7, is 7 less than 6? No. Is 7 equal to 6? No. So in this case, 4, 5, and 6 are solutions. There's numbers I could plug in that would make that equation or that inequality work. All right. If you had your printed notes, we're actually going to jump into the next lesson a little bit, just because these are two shorter ones. We're going to combine them together. So we're going to take some phrases and we're going to translate them into an inequality. Not just an inequality symbol, but an actual statement, an inequality problem. Okay, think back to our expressions unit when we looked for keywords. So this one says 8 is greater than P. Well, greater than looks like that. 8 is greater than P. That's it. Next one, M is less than or equal to. Well, if you look back at your notes, less than or equal to looks like this. M is less than or equal to 19. So in this case, you're not answering anything. We're just writing in inequality form. Here, the product of B and 7. Well, product means to multiply. So we're going to multiply 7 times B is less than 25. So less than 25. But we kind of keep the pieces in the order they are in the problem, and we're just plugging in that inequality between the two sides. A number greater than or equal to 11. Well, greater than or equal to looks like that. I want it to be at 11, and it says a number. Well, I don't know what number they're talking about. I just want any number that's greater than or equal to 11. Well, that doesn't mean make up a number. That means put in a variable, because it could stand for any number that we want to put in there that's greater than or equal to 11. So the key is look for those pieces, kind of know what your variable is, what your endpoint is, and then look for those keywords to tell you what inequality symbol to use. Now, as we get to some bigger problems, we're going to start to see some different vocabulary. They're not always going to come right out and say less than. They might say fewer than. Well, fewer than is the same as less than. Okay? More than, well, that's just a fancy way of saying greater than. So get these terms jotted down along with what inequality symbol goes along with them. Okay? At most, or no more than, that means that's the highest the number can go. That means it's okay to be less than that number, because you can't go bigger, but we can be smaller, or you can be equal to that number, less than or equal to. So at most is that's the highest it can be, but it can definitely be lower. So it can be less than that number or equal to it. At least or no less than means you got to be this number or higher. That means greater than or equal to. Okay? So look for some of those phrases or for some wording that makes you think of that idea, so that way you can kind of put it into our inequality. So this one says, Jessica spent more than $5 at the arcade. So we've got Jessica and we've got $5. So maybe J and 5. She spent more than. Well, more than is really just another name for greater than. So we put in our greater than symbol. So Jessica spent more than 5. So we want numbers that are bigger than 5. There were at least 200 people at her graduation. So we have some people, and we know we're dealing with the number 200. At least, if you see up here, at least means bigger than that number or equal to that number. So greater than or equal to. Okay? You will find inequalities work much, much, much easier if you put the variable piece in front of the inequality and the number after. If you switch those around, it throws off your whole inequality and can cause us to make a lot of mistakes. All right, last couple. If you are handwriting all of this stuff out, because I know not all of us have our note packet, it's okay not to write down all of these. I still want you to write the inequality with me as I do them, but you don't have to write out the sentences. For those of you who already have the note packet, you can just go along and do them with me, but I don't want to save some people all that writing because I know we've had a lot this video. So you must be over 12 years old to ride the go-kart. Well, you have to be over 12, so I want numbers that are greater than 12. And you want to go in go-karts, so maybe we call it G for go-karts. And it doesn't matter what variable you use. We just know that over 12 means greater than 12, so we want that greater than symbol. A pony is less than 14.2 hands tall. Hands are an old-fashioned measurement. You would literally count how many hands you could stack up and how tall something was. So this one's pretty straightforward. Less than 14.2, and then pick your favorite variable. This one's dealing in ponies, so maybe I pick P for ponies. Next one, you must be at least 16 years old to have a driver's license. So maybe we call it D for driver's license and 16. Okay? We always use the number that's there in the problem. At least, well, think about it. How old do you have to be to get a driver's license? You have to be exactly 16, equal to 16, or greater than 16. So greater than or equal to 16. You have to be 16 or older to get a driver's license. Next one, to use one stamp, your letter must weigh under 3.5 ounces. So I know I'm dealing with 3.5. Let's call it L for letter. It must be under 3.5. So think about what inequality symbol means lower than our number. Well, that means less than. The letter has to be less than 3.5 ounces. And then the last one, we're missing a word here. You must be no more than 100 pounds to jump on the trampoline. So the trampoline has a weight limit on it. You can't be too big because you might break the trampoline. So let's call it T for trampoline and 100. You must be no more than. That means you can't be over 100, but you can be under 100. But it's also okay to be equal to 100. So if you says no more than 100 pounds, it means you can be 100 pounds, you just couldn't be bigger than that. So you can be less than 100 or equal to 100. Okay? This gets easier with some practice, and you're going to do that for your activity tomorrow. But look for those keywords. Put your variable piece first, your number second, and then fill in the appropriate inequality.